Okay, let's talk about defining how to define a function. So we define a function like this. We put a parameter list in here, and then we have some expression over here that's going to do something with these parameters, generally speaking. And what occurs over here is usually going to be in curly braces. That's called the function body, and that's usually going to be in curly braces. However, note that what I wrote here is definitely not something I'd want to put in to this line here. It's just I'm just giving you the form. Okay, so here's an example of a function. I'm calling it CV. And so, like I said, you write function, and then you put the parameters list in there. Now I'm just putting in one parameter, just x. And then you say what you want to do to x here. So I'm taking the standard deviation of x and dividing it by the mean of x. The standard deviation divided by the mean. So like that's a kind of balancing the standard deviation by the mean, right? It's like if the mean is bigger, then this thing is going to be smaller. Right? Even though you have a big standard deviation, if the mean is big, then then this result will be smaller. So this sort of says if you have large number, then the standard deviation, a large standard deviation is not as important as if you have if you have a small set of numbers, then the standard and a large standard deviation, that's more important than if you have I'm sorry, I don't want to say a small set of numbers, but I mean if the mean of a set of numbers is small, then large standard deviation has more meaning than if the mean of a set of numbers is large and you have a large standard deviation. So that's maybe what this is designed for. Actually, this has a name. It's called the coefficient of variation. So once you define it, then you can use it. So let's define it by hitting enter. And then we can use it by CV. Now it's supposed to take a parameter. So I should put in some parameter. So how about if I don't have anything set up right now to put in there. So suppose I make a vector to put in there. Suppose I do concatenation vector and 1 through 10. So that's a vector, or this is a vector. So I'm going to put that in there. Now I didn't actually need to write this C. I think you could just create the vector without this C. But anyway, let's do it. So it's what's it gonna do? So this is a vector 1 through 10. It's going to calculate the standard deviation of that vector and the mean of that vector. It's going to divide the two and report back the result. So that's the answer. Let's see. I wonder if I'm pretty sure I didn't have to put this in there. Right. And now once you have defined a function, it's back here. Once I've defined a function, I can use it anywhere. So I'm going to try and use it. I need a list. Do I have any lists here? Maybe new list might be a list. Let's see, new list. Yeah, that's a list. But that's not a numerical list. I want a list of numbers. Okay, maybe test set up here is, yeah, a list of, I mean, it's a data frame, but I think we can treat it as a list. So I can do this. The lapply we learned about before, maybe you saw that video. I'm taking the test set and using this newly created function within the test set. Within lapply, and it works. Now here was my the definition of the function. Actually, so if this is all on one line, you don't actually have to put these brackets, these curly brackets around there. But if it's in more than one line, you would. So let's try doing it this way. Suppose I wanted to change this function. And first of all, I'm going to put it on more than... No, I guess you can't do it that way. So So you have to do, let's call it CV1 equals function x, and then like that. And now I can say if x equals 0, I have to put brackets around that. Okay, sorry, I moved it up here. So here's CV1 function, and then I put the curly bracket here, then I start to write the rest, what it's supposed to do. So I wrote if x equals 0, return x, error x is 0, and I put brackets around that, else return the same thing as before. I guess I could have written else CV. Actually, I'd like to try that, and then close this. And so then I tried CV on 0, and it gives me error x is 0. On the other hand, I tried to create a new vector with 3 zeros and put that in there, and it did say x is 0, but it says warning, if x equals 0, return this, else that. The condition has length greater than 1, so the condition, if this equals 0, this x has length greater than 1, and only the first element was used. So it gave me this, it did give me this back, but only the first element was used. So I could have written it, well, I'm not going to do it now. Okay. So R also allows for what are called anonymous functions. These are functions with no name that are useful for one-liners. The preceding example using CV and lapply can be shrunk to one line by using the anonymous function that is passed directly into lapply. So before we had lapply test set and then CV x. No. Before we had this, which gave us that, but instead of defining CV, a function called CV, we could do it just like this. So never having created a function called CV, we could run this lapply like this. Now if you remember, this lapply applies, as I recall, column by column. It's going to, in test set, it's going to apply the function, and here I'm saying apply this function, which is a kind of combination of functions, taking each column and putting it, replacing x by that column. So it will do the same thing. No? Sorry, I forgot. I have to call it, I have to say that it's a function. I have to say that it's a function, I have to put, I'm basically defining the function right here. Remember, I think I could put, I might be able to put curly brackets in here, but if it's a one-liner, you don't need to. So it worked there. I wonder if I put the curly brackets in there, if it would still work. Yeah. And here's just a little bit of a review about functions. So the return value, all functions return a value. Normally a function returns the value of the last expression in its body. You can also use the return an expression. So we used here, we said return here, but you don't have to do that. And also, well, in this case you'd want to have that return, but if you just at the end said else sd slash mean of x, that should work, that you don't actually have to put the return there because it returns whatever is the last statement. Next is call by value. function parameters are called by value. In other words, if you change a parameter, then the change is local and does not affect the caller's value. This is sometimes called passed by value. Passing a variable by value makes a copy of the variable before passing it onto a function. So if you make changes to that value, it doesn't change the variable. This means that if you try to modify the value inside a function, it will only have the modified value inside that function. Once the function returns, the variable you passed it will have the same value it had before you passed it into the function. Okay? Local variables. You create a local variable simply by assigning a value to it. When the function exits, the local variables are lost. So that's inside the function. If you create a variable, it's called a local variable. It's just local when that function is running. Conditional execution. The R syntax includes an if statement. Loops. The R syntax also includes for loops, while loops, and repeat loops. Global variables. Within a function, you can change a global variable by using the assignment operator, but this is not encouraged. Local variable. Sorry, but this is not encouraged. Local variables. You create a local variable simply by assigning a value to it when the function. Oh, I think we did that already. Conditional execution loops. Global variables. Sorry, we did that already. Okay, that's all.